Thanks, Jason. I'm here today with John Elsner, the Vice President of Sales for CalAmp. And CalAmp's been a partner of GPS Insight for a really long time, almost since our inception, for GPS hardware. And John comes to the table today with a lot of insight and a lot of background in the GPS space. He has really seen this technology emerge from its infancy to where it is today. So thanks for joining us.
Hey, thanks for having me.
So we're going to talk a little bit about his history in this space and how far technology has come. We're going to talk about data anomalies that some of our customers may be experiencing. And we're going to dive into diagnostic data as it pertains to light-duty and heavy-duty vehicles. And we're also going to jump into the future a little bit and talk about what kinds of products are coming in the next few years as it pertains to GPS technology. So with that said, you've been in this industry for quite some time. Can you provide some detail and history on your experience so far?
Sure. I started in the telematics space before it was even called telematics in the mid-90s. Before there was even really GPS around, it was very, very expensive. I started with a company, one of the first players in the space, and they ended up putting a network together for technology that located vehicles, but it was based on paging, believe it or not. So they ended up having to put towers in certain cities, 5 metropolitan areas to be exact. And that technology worked pretty well, but it was very, very expensive to support and maintain
sounds like it.
And roll out. So the company went through a series of different owners, and eventually they laid off most of the company. And so a few years later, I ended up with a couple of former employees that were some engineers, and they had a little boutique engineering company called Technocom, and they specialized in location technologies and built some of the first GPS units way back when in the nation. And in those days, they were really fairly advanced in what they were thinking, and they put some very interesting technology in the units, and we can talk about that a little bit later. But it was sort of an interesting time because we were early on, and we were bought by CalAmp about 12 years ago, and at that time we're doing 15,000 units a year, and now we're doing about 2.5 million units a year.
2.5 million units a year.
A lot of units, right.
So that's a clear indicator of the type of adoption that there's been in location services or location intelligence over the years.
Yeah, absolutely. I mean, the customers were basically the same. There were, service companies and some delivery companies, some transportation, but it took so much more in the early days to have those customers understand that telematics has a really clear return on investment.
Okay.
And so those days there's a lot of education, just a lot of trying to get people to understand that the money spent in telematics is actually better and more useful and more profitable than the money spent on tires, right?
Yeah.
So
I feel like we've only just come over the hill on trying to educate the market and into the types of return on investment that they can get from GPS technology. I feel like when I first started working at GPS Insight, there was a lot of education to take place. People really didn't understand, like you're saying, where the return on investment came from a dot on a map.
Right.
And now it's obvious, and it's something that almost every business is investing in.
Yeah, the adoption's clearly.
Yeah, it's sky high. So seeing as GPS devices are an essential part of tracking vehicles and other assets, can you tell us a little bit about what CalAmp does in partnership with GPS Insight?
Sure. I mean, we make the hardware that's the foundation of a good solution. But more than the hardware, I mean, the hardware has to be reliable, it has to work, it has to be location. But really, there's some brain power that goes into us. And this is what was so innovative when we started off in this industry. The brain power is essentially, it's like software for an application for a phone today, but it's called firmware. It's the brain power that goes into a device. And we create this sort of capability to be able to create these, I want to call it sort of these scripts. And these scripts allow you to configure a device for different use cases. And it essentially allows you to put in sort of conditional statements. If this happens, then do this. Okay. And it makes it easy for GPS Insight then to take that and apply it to different industries, whether it's on a lawnmower, whether it's on a delivery truck, whether it's on a service vehicle, whether it's on a school bus. In fact, there's a funny story about school buses which might sort of demonstrate kind of how this is used. Okay. This is about 12, 13, 14 years ago. We had a customer that sold to school buses, school districts. And there was a situation where a child was locked into a school bus at the end of the day. And so what happened is the driver's supposed to go at the end of the day and walk to walk to see if there are any sleeping kids in the bus. If anybody fall asleep, and one child fell asleep, and the driver didn't go back and check, and the child was locked in a bus in North Carolina, I believe. And so there's no lemonade out of those lemons. So what happened is there was a panic, of course, and they said, let's go purchase some buttons and put them at the back of the bus, so it proves that the driver actually made it to the end of the bus and to press that button. And so they were looking at technologies like two-way radio to accomplish it, and trying to create a whole separate system to do this. And our customer was astute enough to say, hey, you've already got a telematics device. You can use that. And they said, what? That does location. And I said, no. Think of what it can do. All we have to do is connect a button to the unit all the way to the back of the bus. It becomes an input. And so what you do is you set up a script to reflect that. And so what does that mean? So that means, well, the script would go something like this. So you go into the yard, which is the geozone. So it says, hey, I'm in the geozone. And when I turn the vehicle off, I set a timer. Let's just say the timer was 4 minutes. So it takes 4 minutes for that driver to go back and press the button. If he presses it within 4 minutes, nothing happens. If he or she doesn't press it within 4 minutes, then they send the level 1 alert, which would be a note to dispatch, and I think they were blinking the lights on the vehicle. If another 4 minutes expires, then they would go in and start honking the horn. So it shows you kind of like the layers of complexity you can get into in terms of scripting a device to be able to accommodate a specific application or use case.
So they're incredibly smart devices and incredibly configurable. This firmware really seems like it can help our customers with just about any kind of challenge they might have. That school bus one being pretty unique.
So what happens then for GPS Insight, you can then take that device, program it, use the information, extract the information that you need to present your customers for different types of scenarios, right? Whether it's a school bus or whether it's a transportation truck, a delivery of fuel. There's all kinds of trash truck. There are all kinds of various scenarios that they're used for, and you can take the same device and make it behave differently depending on the needs of that particular customer.
Right, and that's essentially the relationship that they provide. These devices provide all this amazing data, and GPS Insight really just takes that data and makes it consumable for you guys.
Right.
So what have been some of the challenges to the technology that you've witnessed since joining CalAmp?
The typical technologies that we face, typical challenges that we face are the following. One is you've got to have a device that's reliable, and it's hard to do it, get to a reliability when you're expected to have the most competitive device at very low cost. And the other part to that is we don't control the environment. So what does that mean? So we have to have a device that supports GPS. That means if you have metal in a vehicle or different environments in a vehicle can impact the GPS quality. We buy a cellular radio, we put it in. We don't control the cellular radio, we don't make the cellular radio. So that's something we don't control. We don't control the network it's on, whether it's Verizon or AT&T or the others. We don't control that network. When they have problems, we have to solve the problems for them and for the radio manufacturer. And we also don't control the environment. Think about it in terms of the installation. We don't control the installation or the driver, and drivers are known to do tampering. So all those things go in to try to make a unit. When someone calls and says it doesn't work, what does that mean? There's a lot of digging in to get to that answer, and that's where the partnership really works well. So one of the things that we do as part of the partnership with GPS Insight and our other customers is we provide a lot of support. So we have about 20% of our staff is just working with our partners to uncover those problems when we run into them.
Okay, that's a huge reason why we're partners. That's the kind of service that we want to deliver to our customers, and certainly the type of service that we want to expect from our partners like yourselves. So that's fantastic.
And it's not really a, I guess it's got to be a partnership, because there are scenarios where we rely on GPS Insight to get us the information we need to help get to the bottom of a particular issue.
So it's important for our customers to realize that could be a few things that are happening within that device. It may not actually be a faulty device that you're experiencing. It could be any one of these three other factors that John has mentioned. So when you are concerned about the reliability of a device, just call into GPS Insight support and we will walk through it together to figure out if it's any one of those three or if it is in fact a faulty device. So data reliability is incredibly important for our customers as they're trying to manage crews and technicians out in the field, and they're using this data that's coming from the field to make important decisions. So as it pertains to data anomalies, can you share some of what these anomalies are and how they should be dealt with?
Yeah, so everybody should understand, it's like a cell phone. Occasionally a cell phone, you'll have a hiccup and you'll drop a call, right? We all realize that, we all deal with it, it's just part of the day-to-day. The same kind of thing happens, if you think about hiccups, it happens with GPS. Why? Because GPS, essentially what you're doing is you have a GPS receiver and it's listening for signals from the satellites that are coming in, and it's looking at the timing of when that signal hits the GPS satellite based on the location of the satellite in the constellation. So it has some very precise algorithms that work to tell you where you are on Earth, what particular latitude and longitude you're at. And so sometimes those signals can get delayed. They can bounce off of glass, they can get delayed through concrete, they can also bounce off of metal. Sometimes it's the nature of radio frequencies. And so they don't always get through on time. And if they don't get through on time, the timing's impacted, the algorithms are impacted. And what you see sometimes is a jump. We call it GPS drift, where you have a jump, you literally will see a unit on a map, and then the next location might be 20 miles away, and then it'll pop back in a location or two back to where you expect it to be on the map. So that's part of the technology. We do what we can to minimize that in our devices. You do what you can on your back-end systems to minimize those jumps or that drift, but it is part of the technology. And so if you have customers who are seeing that, first thing to do is you want them to check their sort of activity logs or their breadcrumbs to understand, hey, is this just a one-time jump, or is this a pattern, or do I have a real problem? And if there seems to be something more than a one-time jump, then call GPS Insight and dig into the problem. It might be where it's installed, it might be tampering, it might be a variety of things. But give it the opportunity to make sure you understand that these hiccups happen, and then check to see, okay, is this just a hiccup or is this a pattern worth calling in on?
I know that many of our customers, when this does happen, start to really doubt the quality of the data that's coming across, and that's really shouldn't be the case, because just like all technology, there is a hiccup here and there, and it does usually bounce back. Someone's not going to jump to another state and stay there. The next couple of points later, it will go back to where they were. And you can really just write that off as an anomaly and not take action on that. We do suggest if you do have a question on it, though, please call us and we'll talk it through.
And the other, and it could be very often just environmental. It could be either in a downtown area with buildings. It could be under trees. I mean, even those little parking structures, all those kinds of things could impact it.
So in addition to data integrity, like we've been talking about, diagnostics are a huge trend right now. All customers across most industries are expecting to get dashboard odometers, MPG data, diagnostic trouble codes, speed even, right off of the engine's computer. So what is CalAmp doing to ensure that this diagnostic data is as accurate as possible?
That's a great question. It's interesting that the industry started way back when with emissions, and that's really the only thing that the ports are used for on light-duty vehicles is for emissions. That's the only requirement. And so all the technology was based on emissions technology. It wasn't anticipated that folks like us would be taking odometer, miles per gallon, fuel levels, that kind of information from the vehicles. So all that information is kept confidential by the car manufacturers. And so what that means really is that we end up having to reverse diagnose and reverse engineer a lot of these cars. So if you really think about it, it's every year, make, model, and engine type that have their own unique code. So odometer might vary tremendously, even on the Ford F-150s across the whole entire line. So a 2015 might be very different from a 2016. And the way we have to get that information, we have to go out and rent a vehicle or get access to a vehicle. We have to scan the information coming off the computer system. and we have to take that information, analyze it, find out where that odometer, as an example, it is, and then be able to take that odometer and program it in and say, okay, now for the Ford F-150, year 2016, this is where you get odometer. So it's a pretty complicated process.
Yeah.
Then in addition to that, we have to figure out how to do that real time. So when you plug a unit into the vehicle, we have to say, oh, okay, we have to identify that vehicle. It goes through a series of, there's different protocols or different languages or different sort of interfaces on the vehicle. You say, okay, we're looking for that vehicle, or we need to first identify the vehicle, so we have to find the VIN. Okay. Right? So we got to go and we say, got to look for the VIN. So protocol number 1, is the VIN there? Nope. Okay, let's go to protocol number 2. Is the VIN there? Oh, it's there. What's the VIN? We take that VIN, we send it back through cellular to our system, and we say, okay, that VIN, oh, we know based on the VIN, that's a Ford F-150 2016. Therefore, the odometer profile is this, and we send information to the unit, we update the unit, and we actually update the unit not only to support those 4 parameters to be able to get odometer and the other types of things we're trying to get. We also will shut down the protocols that aren't used. We'll actually, there's even electrical signals that go on different pins for different protocols. We'll shut those down just to make sure it's a very safe solution. And then we update that unit, dynamically. So now it knows it's a Ford F-150 2016, and because it's that, it now knows how to get the right odometer.
Wow.
So you can imagine, every vehicle out there, you've got to reverse engineer. And odometer you would think is very common. Not so. It's only available on about 30% of the vehicles. So
wow.
The remainder of those vehicles have to be reverse engineered.
So 70% of them you guys have to go out and get.
And that's just odometer. What about
yeah,
other parameters,
else.
Right? What about fuel rates or fuel levels?
Right.
Or,
so you have an entire team?
RPMs.
That does
yeah, we
this?
have about 15 engineers that do this full time. And so it's a pretty massive task. We've now, I think, are out there with about 1.3 million vehicles that are installed with light duty diagnostics on them, and about 400,000 with heavy duty diagnostics.
So what percentage of makes and models would you say that CalAmp has?
It's really hard to know. So the standards, we focus on 2008 and after, because that's really when the standards for what we call the OBD2 or the emission standards started. And so we think that we pretty much cover, in terms of more of the generic parameters, we cover about 80% of the vehicles. We have installed base of about 1.3 million vehicles on light duty and another 400,000 heavy duty vehicles. So we think we're in North America at 80% or more.
That's actually a pretty high percentage. I didn't expect you to say 80%.
It's high percentage, but there's always one vehicle and one fleet that says,
yeah, right.
oh, okay, well, it's not, that I'm not getting that particular parameter correctly, and it could be variant. And sometimes we've even seen fleets or OEMs come out with fleets of vehicles where they change the codes mid-year. So
great.
Yeah. So you think
so
you got it covered,
back.
and you have to, 2014 is working. Oh, wait a minute, they made a switch at one of the plants in the middle of 2013 and 14.
Oh my gosh.
So you have that going on as well.
So is it safe to say that CalAmp has the best set of diagnostics in the industry?
It's really hard to know whether we have the best set, but I think we have certainly one of the more complete, because we just have so many vehicles out there. So it is it's an industry in its infancy. Every year by year, month by month, we continue to grow. But I can't imagine there are too many other companies that have more experience in this space than we do.
Yeah. So again, realize that if you have an F-150 that's getting odometers and you have a Silverado that isn't, it's not that the device doesn't work, it's not that anyone is not following through with providing the data you've expected. It's just that we can only get what we can get, right? You have an entire team that's out there pulling everything they can off the device or off of the vehicle that the OEM is even allowing you to grab, but it's limited.
It's limited, and it's a very manual process. We scan the vehicle and we look for, hey, what might be the odometer, what we call it a parameter. In other words, the odometer indicator. You have to go through the code and look at what's coming off the vehicle and say, I think that's it. And then you've got to test it, validate it, make sure it works.
So shifting gears just a little bit, what do you foresee the next 5 years looking like from a GPS hardware perspective? What technologies will be available that our customers may have access to?
You know, it's sort of an interesting question. It's hard to predict the future. What we've seen is there's hundreds of millions of iPhones and tablets out there and smartphones out there. And that means the cost of technology has come down, right? In the last 10, 15 years, you know, the cost of accelerometers, you know, when your phone moves, that's an accelerometer that watches the games you play, right? So the cost of those components have drastically decreased. The cost of GPS receivers have decreased. The radios have decreased. So all that's come down. But now what's happening is that technology has become so powerful that I see that the telematics devices will make a sort of a overall change, whether it's us or our competitors, will start to do more Linux-based or more systems with more devices with operating systems. Today we don't have operating systems in devices because we want to keep them affordable.
Right.
Well, now it's getting to a point where that cost of having the processors needed to run a Linux-based operating system have come down. And with that, you now have a really super intelligent device because you have an operating system, right?
Yeah.
Now it becomes more like a phone. So then you're now in the world of IoT, the Internet of Things, where you can start to hook up all kinds of sensors. And the sensors in the vehicles that are coming, I think we see things like cameras, maybe distract a driver, ways to keep a driver off texting, maybe ways of looking at a driver for drowsiness, to watch for sleep patterns. I can see all of those sensors being placed around a vehicle. Could be even levels of collision warnings, both forward and backward collision warnings, maybe lane changes. I think those sensors are coming, and they're going to need a central hub to gather that information. And the same thing we do today, report that information, right? It could be, today we report things like, a little bit of driver behavior, a little bit of, we have some very interesting aftermarket crash technology which detects the severity of crashes. We can do that today in our units. But the intelligence that a Linux operating system or other types of operating system will give us a lot more intelligence and visibility of what's going on with the car, which eventually ends up helping with driver safety and safety of the vehicle and its environment.
So just like cell phones were only for making phone calls at one point and turned into mini computers that are now sitting in your pocket, these GPS devices, although smart and very configurable already, are going to turn into mini computers inside of the vehicles as well, in the cab.
Absolutely, absolutely. And in fact, you're seeing a little bit of that with for those of you who don't know, the ELD mandate, the mandate to automate the hours of service. You're taking information from the vehicle system and presenting that to a tablet, and you've got to do some intelligence there. There's a lot of overlapping of some of that stuff. So some of the consumer technologies that we take for granted today are working their way into some of the smarts in the device, and those are, especially when they become a little smarter with the operating systems, we'll see a lot more of that.
So it's great to hear that safety is an initiative for CalAmp, because for many of our customers and for GPS Insight, safety is a huge initiative. We realize how important it is. So to hear that you guys have things that are coming out that are going to improve safety for drivers and the general public,
yeah,
for that matter. That's
right.
great.
We'll be working with GPS Insight too, as you develop applications, try to work together to come up with something special.
Yeah. So in summary, GPS technology has come a long way since you've entered this space. Diagnostic data is incredibly difficult to get your hands on, and is incredibly difficult to get to our customers. But you guys are working tirelessly on this, have an entire department that does it, and your data is probably the most accurate and most robust on the market, I would assume. And on top of that, it looks like you guys have a lot of great safety technology that's coming out in the next few years, which is great for our customers who really care about their safety initiatives, and we look forward to being able to offer that to them in the near future. So thank you for being here today. I learned a ton. I'm sure our customers did as well.
It's been a pleasure.
Appreciate
really
it.
been a pleasure.
All right, back to you, Jason.